Today's lesson is the last one in activity 5. We're going to be doing some more with compositions today. So we're going to evaluate compositions of functions. So open up to page 84 of your book and let's go ahead and get started. Okay, so a composition of functions forms a new function, okay? And we kind of write it in this form, f of g of x, that we talked about yesterday. And that is a composition of f and g, where g is the inner function and f is the outer function. I kind of talked a little bit about that yesterday in the last video, okay? So I'm just going to jump down to the table down here, number 2. Okay, so we're going to use the table of values to evaluate each expression. So we have f of 3, g of 3, and then c and d are going to get into some compositions where we're combining functions together. Now, this little math tip on the side here, the order does matter when you're composing functions. So if it says g of f of x or f of g of x, those are two different functions. So order definitely matters. Okay, so let's go ahead and solve these. So we're going to use the table of values to kind of give us our answers. But if I had to find f of 3, I'm going to go ahead and use this f of x function. So if I put in 3 as my input, what's my output? This answer is 1. Okay, so again, we're kind of, this is your input, and then the function will give you the output. So look at the value for x. Remember, a function is written like this, f of x. So they're giving you an x value, and you need to get the y, or the output. So why don't you guys try B? Find g of 3. What would g of 3 be from that table? Okay, well, g of 3, here's the value for 3, so that function would be 2. 2 at that value. Okay. So the next one's what we're going to do is find a composition. So what that means is we're going to plug the function where we have our inner function and our outer function. So we're going to start with this f of 3. So we're going to evaluate the inner function first, and then that'll help us to do the outer function. So if I have to find f of 3, well, we already did this one. F of 3 was 1. So I can replace that for 1, like this. Okay, so instead of f of 3, we evaluate that first. We get the number 1, and I kind of substitute that in. So now what we have to do is find g of 1. So if I find g of 1, well, here's 1, that answer would give me 4. So that's my final answer there. Okay, so on D then, they want us to find f of g of 3. So again, different problems because the order is different, but let's find g of 3 first. So g of 3 is going to be there, so that's going to be 2. So we're going to replace g of 3 with 2 and now solve that function. So now we have to find f of 2. So back to the f function. F of 2 is going to give me the answer here, which is 2. Okay, so that's what it means to compose functions. We're doing two functions and putting them in together. So we're evaluating them as one piece. Okay. I'm going to jump to number 7 on the next page. Okay, so this is kind of more what we're going to see on tests and quizzes, where we have functions f of x, x squared, g of x is 2x minus 1, and h of x is 4x minus 3. So we're going to evaluate these. So we're going to start with A, where we have to find g of f of 2. So again, we always start with our inner function. We're going to evaluate this function first, f of 2. So f of x is using the x squared function. So what I have to do is plug this in for x. So that's going to become 2 squared, which is 4. So now that we evaluate the inner function, I'm going to evaluate this now for g of 4. So our g function is 2x minus 1. So if I plug that in for x, that's 2 times 4 minus 1. So 2 times 4 is 8. 8 minus 1 is 7. So that is our final answer. So again, I evaluated the inner function first, got that value, and then I plugged that in for my outer function. So let's do one more. We're going to find g of 2. So it's f of g of 2. So we find the inner function first. So let's plug in 2 for g. So we're going to find 2 times 2 minus 1. That's g of 2. So 2 times 2 is 4. 4 minus 1 is 3. So now that we found g of 2 to be 3, now I'm going to find f of 3. So again, we're just kind of evaluating this one first so we can substitute it in for the f. So that means we have f of x was x squared. So if I plug that in, 3 squared gives me my final answer of 9. Okay. All right. So this is number 8 is kind of what we did in last night's video, but it's good practice to do it again. So we're going to rewrite and make a composite function. Okay. So meaning the function means that you're still going to have your variable. There's no number we're evaluating for. So we're just going to go ahead and find g of f of x. So this is kind of opposite. Yesterday I said we start with the outer function and I would rewrite this. So my g function, I'm just going to rewrite as 2x minus 1. But in the place of the x, okay, I'm going to leave a blank. And what do I put in that blank? I put in the f of x function. So f of x is x squared. I'm going to substitute that in. So now we have 2 times x squared minus 1. Just gives me that function, 2x squared minus 1. So this is g of f of x. Okay, so why don't you guys try b? So this one you're finding f of g of x. So start with f, that's your main function. Okay, and then you guys are going to have to plug in g of x for the variable. Okay, so this one was kind of tricky, so let's set it up. So f is my main function, so that would be x squared. So in the x spot, where do I plug in? I plug in my g of x function. So in that spot, I'm going to plug in 2x minus 1. So 2x minus 1 squared. This is actually a lot tougher of a problem than I thought it was when I told you to try it on your own. So remember, when we square something, it means that we have to multiply it by itself. So we actually have to multiply this polynomial out. So 2x times 2x, that's 4x squared. 2x times negative 1 gives me negative 2x. And another negative 2x gives me negative 4x plus 1. So that's this function. So that one actually had a little bit more work than I thought it did. So there's that final answer. Okay. So now if I plugged in these functions, the g of f of 2 or f of g of 2 into our new kind of composition functions, we should end up getting the same value that we got when we evaluated. But I'm not going to go through that right now because we already did that part. So let's just kind of end on the last page here. Okay, so it's the same functions from the previous page, so I just kind of copied them back over. But I'm going to have you guys try 10. Okay, so first I want you to evaluate h of g of 3 and tell me what you get. Okay, if you did everything correct, you should have got the answer of 17. Okay, so we'd have to find g of 3 first. So if I plug in 3 to g, that's 2 times 3 minus 1. So that gives me 5. Then once I found that, I'm going to find h of 5. So h of 5, that's 4 times 5 minus 3. So 20 minus 3 is 17. Okay, last I want you to find the composition function. So if you don't like it written that way like hog, okay, we can rewrite it like this, h of g of x. So again, start with your outer function, rewrite it, and then where the x's, leave a blank. What you put in that blank is that g of x function. So go ahead and try that and tell me what you get. Okay, if you did it correctly, you should have got the expression 4x minus 3. So if I start with h of x, that's 4. We're going to leave a blank. I'm sorry, I looked at the wrong answer. That's totally wrong. Just looked at the wrong thing. The answer should have been 8x minus 7. Sorry about that. So let's go through the work and see how I knew that was wrong. There was no way that was the answer. So 4x minus 3, inside the x, what do I put in? I put in the g of x function. So now I just got to clean it up. So I'm going to distribute here. That's going to give me 8x minus 4 minus 3. So that's how we got this answer. Okay, so again, compositions are combining functions together. So I'm taking, when we're evaluating, we're kind of doing it in two parts. We evaluate the inner function and then use that to plug it into the outer function. When we're writing composite functions, we're starting with our main outer function. We rewrite that function. And anywhere we have a variable, we leave a blank spot. And then we fill in that blank with the inner function. Okay. All right. So that's the end of today's notes. We'll definitely do some practice in our class tomorrow, but I'll see you then.